All right, what I would like you to do right now is get out all your tiles. We get to play with them all. Oh no, now we have more to think about. I threw too many at you. Oh, I hear what you're starting to do, which I really wanted you to do. Ooh. You have a chance. I'm giving you 2 minutes. Play. Remember my rules for playing. They may not be shot anywhere, so no tiddlywinks. That is not okay. They may not be shoved into any body part. Unacceptable, okay? But as far as the rest of the play, they can make pictures or anything, but what I want you to do while you're playing, and please discuss at your table groups, what do you notice? I already heard it going on. Ooh, I see this color, I see it. What do you notice? And there's some really big things to notice. Talk to your table groups, let them hear you. Okay, you know what happens at the end of playtime? Are we allowed to keep playing? No, I'm sorry. So shuffle it back up. And what I really like you to do that would help is if you sort them into piles. Big squares, strips, little squares. That's kind of how I call them. Big squares, strips, little squares. It'll be easier for you. It doesn't have to be in any all facing up or down, whatever's comfortable for you. But we're going to grab them like that, so we need them sorted. Now, we are not playing with them. After this point, I shouldn't see boats or people or flowers or anything like that after this point. We are focused on what we're doing. So I gave you a chance to make what you had to make. Now with that, we're done.
Yes, we also had to work while.
Oh, darn it. Learning while playing. Hate that. Okay, we've been playing around with the small squares a little bit. What does this yellow represent? Positive what? Positive, Dylan, go ahead and say it. Positive 1. Are we okay with that? Wait, no, some people are still moving things, and I don't know if they're okay with that. I'm looking down there. Bryson, are you with me? The little yellow we've considered positive 1. So what are some of the things that we notice? If that's our, what are some of the things that we notice? So this table group, you're going to tell me one thing that you notice. Miss Sydney.
All of them have the same color for negative, but all of them don't have the same color for positive.
Interesting. All of them are same color. So did you all notice that they all have red on one side? Okay, so they all have red on one side. And they're all different color for what she's saying is positive and negative. And you're absolutely right, Sydney. That is how they're representing positive and negative. Excellent. This table group right here, all right? So why don't you go ahead and give me one thing that you notice?
They're all different shapes. They're all different sizes.
Awesome. That is a huge deal. And that's very important to how this goes. Paloma, your group in the back there, can you give me something?
They all fit into each other. Yeah, because these five of these fit in here, and these fit in the big square.
Okay, so she says 5 little ones fit in the strip. Did you guys did you see that? Did you notice that? Nod your heads if you noticed that. Excellent. Group back there, what did we notice?
5 of the strips fit into one square, and then 25 of the little ones fit into
Okay, so they made some exchanges out, right? 5 strips into the big square, 25 of the little ones in the big square. Excellent. Go for it, Kaylin. What did you notice? They all have different colors for positive and red for negative. Thank you. And Elizabeth, you have one more thing to say?
That not exactly 5 of these squares fit into a strip. There's a little extra room in the squares.
Huge, important fact. Did you hear that? It's 5 squares, but not quite. And the same thing with the strips. It's 5, but not quite. Test that for yourselves. Because I think you were pretty sure it was 5 exactly. But now, because we're talking about mathematics, we need to be as exact as possible. No, well, the rulers actually might prove it to you if you don't think so. Okay? Prove it to yourself. Elizabeth is absolutely correct. Okay. At the top of your green note maker, it says, this is at the first side that has Algebra Tiles Note-Taking Part 2. Turn your green paper over so I can see. Read. You're not quite where I am. Excellent. Wait, Matt, you're not quite where I am. The side that says Note-Making Part 2. This top part here is a chance for you, and if you have the right color markers, you're welcome to use them on your table. If you don't, you should be fine with just pencil and paper. But you're going to draw what I'm drawing up here on this poster. Okay? The yellow one we said represented what? What was the yellow square? Zachary? 1 unit. Do you know why? If its length is 1 and its width is 1, what's its area? 1. 1 times 1, right? So this is going to be our positive 1. Therefore, our red one has to be negative 1. It's the opposite. Red is the opposite side. Please draw that. And notice I'm keeping negative on the right, positive on the left, just so I can keep them straight from each other, because I'm going to talk about positive all in one group, negative all in one group. All right, now we're going to take a look at what Elizabeth said, because Elizabeth said something brilliant. And what's funny, Elizabeth, is in all the time I've been doing Algebra Tiles, no one has caught that yet. That's pretty impressive. Here's my green, and you can do the same thing with me. Go ahead and put your 5 yellow right on top, or you can do it all in red is fine. It's easier to see with the yellow and green, though, I think. Okay, you get them all nice and lined up, all the way to the one end. And what happens is, you can see it almost, it's really hard on here, but you can see there's this teeny tiny, do you have this teeny tiny strip? But don't they fill it this way, though? There's no leftover along, you don't see like a long strip on down the side, do you? That one's like filled, but then there's this little at the bottom. Okay, so let's put it like this. And we can see that this distance is definitely 1, isn't it? Because they're the exact same length, right? Are you okay with that? So how long is this then? If it's not 5, what is it? I hear 5.5. 5 1/4. 4 1/2. 5 1/8. 1.
I'm thinking 5 and 2 millimeters.
Ooh, 5 and 2 millimeters.
5 and 1/6.
Yeah, do we all agree? Yes, ma'am.
5 centimeters and 1 millimeter.
And 1 millimeter. 5 centimeters, 1 millimeter. Actually, we don't know how it's related to 1. It could be 0.2, 0.3, 0.2, 0.225. It's really hard to tell. So you know what? Since we don't know what it is, we are going to give it a variable. A variable means it varies. Brittany thinks it's one thing. Chrissy thinks it's something else. Dylan thinks it's something else. It's true. You're right. It varies. So we're going to give it the variable x. So if this is an area model, and this has a 1 by x dimension, how big is it? Little boys all going to town throwing rocks at your window. Okay. A 1 times x is x. Or we also can call it 1x. But if you have 1 of something, you don't walk around going, this is 1 ben, 1 ben. This is 1 ben. Right here is 1 ben. You just say ben, don't you? But if you have 2 kids, you need to say there are 2. There are 2. I'm sorry, cracking up these kids out here just trying to stick this thing to the window. It's one of those things that's supposed to walk down the window. It's not quite working for him.
Maybe we just need to close the blinds.
Thank you, Caitlin. Thank you. That's all right. He might get it eventually. It's too good not to stop him. All right, so we'd say we'd have 2 kids. But you don't have to say 1 ben, 1 ben. If there are 2 bens, we should say there are 2 bens. Okay, but 1 ben, we just say ben. Okay? So we have x. So tell me then, if I flip it over and I get the red side, what is that called? Negative x. You guys are brilliant. Okay, so if I flip the red side over, let's draw this for ourselves. This is the opposite of x because it's the opposite side. It's negative x. It's the opposite side. It's the negative x. And they make it green instead of yellow to make you really understand that the yellow and the green are not, it's not 5 of these. It's a different color because it's a different dimension. It's an x. We don't know how long it is. Okay. These are variables. They can change. So the green are variables. All right, let's talk about the blue then. The blue, if you put these guys on here. All right, start lining up the green on top of the blue. Please do that with me. They fit 5 exactly? Nicole? Go ahead. Do you know where I'm looking at? Right here?
Yeah, right.
You can also, but you can do them sideways. Don't do them up and down. I think you might have more room, and then you can put the big square here. So do a small square, a strip, a square, a small. There, she can do it. Thank you. Thanks for fixing that, Chrissy. That'll work. Okay, so we notice the blue has a strip, right? It's off. It's not. It's close, but it's not off. What about the strip going up and down here? Does this fit exactly on the top and the bottom? Look at yours. Fits exactly on the top and the bottom? Okay, so this makes this a little bit different. So let's take a look at this blue. If you move a green on top of it like this, look at what I'm doing and make sure that you believe this. It's exactly a green across, isn't it? Isn't it exactly a green this way too? Okay, they're the exact dimensions. All right, that's going to mean something. This tape is messing with me. It's angry tape, and now it's stuck to the Tupperware. That's lovely. Here we go. Well, that's somebody else's suggestion, okay, to name it a Y. But to get a Y, wouldn't that be a 1 by Y?
Well, that's X by X.
It is an X by X, Reed. That is absolutely correct. This direction is X. This direction is X. So to get the area, and this might be very, very new for you, we'd have to multiply X times X. It is not 2X. It is something called X squared. Why do you think they call it a squared?
Because it is a square.
Because it's a square. Some people think math is random. It is not random. This is 1 square unit because it's a square. This is X times X, X to the second power. And it's squared, the second power, because it suddenly became 2 dimensions. It's not just this little tiny strip or a line. It's now 2 dimensions. So what do you think the red one would be if you flipped it over? Go ahead, James. What is the red one? Negative X to the second power, or negative X squared. Very good. Okay, so would you please draw this the best you can on your sheet? Nicole, did you get worked out with some space there? Good. There's negative X squared. Or let's just do a little exploration as some people are finishing their drawings to see if you can figure these things out. This is the whole key to algebra, what you're doing right now. We're going to be doing some very advanced algebra with these. Remember, X represents what? A variable. It can be anything. I can put in any number for X. X represents any number. In this case, it's probably about 5.2. Okay, so how would I show Y? A variable Y. Is it the same as X? No, because otherwise it would be X. Okay, it would be Y. Reed, go ahead.
X is any number other than X is X and Y are different because like X is any number, but Y is any number besides the one that X actually is.
Okay, so would this work?
Yeah.
Would this yellow strip work?
It could be Y or X.
It could be Y.
Or X.
Okay, actually, and then this one would have to change. So this is a different variable, isn't it? Are these exactly the same?
No.
No, they're not. What about this one? What would that be?
Negative X.
It's orange. I apologize. Can you see the color? On this, it's not coming out very well. It is not red. I'm sorry. It does look red up here. So what could this be? This is yellow. Pretend it's flat. Sorry.
It could be any variable.
It could be anything. So if this is X, this is Y. Give me something.
N.
N, Q, Z. Anything. Okay. Q, N, Z. Okay. So here's X. Here's Y. Here's Z. Each one of them was 1 by some distance. So this is X. This is Y. And this is Z out here. I know I draw Z with a line through it. Habit. So that people don't think it's a 2 in math. Okay, so how would I show something that looks like this? Any idea what that means?
X times X.
Paloma thinks she knows what that means. I like the way she's sitting so quietly.
Multiply them?
Yes. Excellent. This is x times y. So in terms of a space, it means it has to be x going this way, right? How long is it down? Y. It would have to be y. So it's going to be some funky looking rectangle like this.
Cool.
There's xy or xz. I think that one is actually yz. But do you see that it looks like a rectangle? Whereas our blue one was what shape?
Square.
A square, because it was x to the side. It was x times x, which is x squared. Okay? All right. So what would this look like? Ooh, taking you to the next level. Turn to your shoulder partner and see if you guys can think what that would look like. Great. Let's bring our conversations back. I hear some good stuff. X to the third is x times x times x. Shh. Up here. Hold on one sec, Zach. Length, width, then what? Height. It brings it into 3 dimensions. Now we're into a 3-dimensional shape. Okay? It is not foam. It is hard. It's hard. This is a set I'm giving to Miss Garrity for you guys to use. Okay? So it's hard. It's x times x times x. Why do you think we call it x cubed? What shape did it make? Exactly, right there.
Sort of like this, except it would be like all work on it.
I know exactly what you're doing. You've got the right idea. This is a perfect cube. That's why we call the third power cubed, because this is actually what it means. We can do this with a lot of shapes. What if I did something like this? Is that a 2-dimensional figure or a 3-dimensional figure? Zach?
It's a 3-dimensional figure, but it would be fairly oblong.
That's right. It's not going to be a perfect cube. See, this is a perfect cube. Look at this one. It's not a perfect cube. It may be a perfect square on one side, x squared, but then it's y high. Ooh, that sounded weird. Y high. But that's what it is. So this is x squared y. So if I asked you right now, add x cubed, some people are messing with tiles. If I said, I'm not talking about you. I know what we were talking about before. If this is x cubed and this is x squared y, if I add them together, do I get x to the 4th? If I add these together, do they become some other shape? X to the 4th means you need a 4th dimension. We don't have a 4th dimension. 4th dimension would be heat, light, anything added, because you can do length, width, height, but after that, we're out of our world. So we'd have to add another dimension. Heat, temperature, something like that. We'd have to add another dimension. Did that do that? When I put them together, time, did I get a different dimension?
No.
I can add these together. They just have to sit next to each other. They didn't become something else. They just sit next to each other. But that's not, they don't become something else. Okay? So let's go back to what we were doing here. Sorry, Jeremiah. Let's go back to what we were doing here. If I add an x bar and an x square, if I add a strip and a square together, if I add together x and x squared, did I get a cube? Did x squared plus x become x cubed? No, you can look right at it. This didn't make a cube. It's 2 pieces sitting right next to each other. So this is not, whoa, big old not equal to x cubed. But that's the most common mistake in algebra. Students all the time go x squared plus another x is x cubed. And you know right now that can't be. You can't take those things and add them up and get a different shape. Not going to happen. Okay? All right. Now, here comes some challenges. Are we ready? Okay. We're working on our very first objective today. What is a coefficient? How do you model it with algebra tiles? Okay. So the new word is coefficient. Coefficient. Okay. Right now, turn to your shoulder partner and say coefficient. Coefficient. One more time. Coefficient. Coefficient. Okay. Now say it in a funny accent.
This
Read.
coefficient, like 3D shape, like adding the 3D shapes together?
Ooh, no. We're not going to ever put our 3D shape, because they don't. They don't really add together. They just sit next to each other.
Okay.
So we need to figure out what coefficient means. Are we ready? Ready to model with tiles? Okay, excellent. Here we go. You need to look up here. Don't write anything next to coefficient yet. We're going to define it in our own way first. Orlando, were we chit-chatting? Thanks. Show me this on your desk in front of you. Show me this on your desk in front of you. Use your own mind. See what you think. Model it for me in tiles. What do you think that is?
Cheese.
Kaylin, where is it, bud? Do what I ask. Model that with tiles.
I know what I think it is.
Dylan,
Where is it?
3x, do this.
Oh wait, these aren't X.
You're
Okay.
so smart.
Alexa, do you have it modeled? Show me where. Just put your hand. Okay.
Okay, I got it right here.
They even made me.
Okay. Bryson, where's yours, kiddo? Okay.
Let me come a 6.
All right. I see a lot of different things. You know what 3x is? 1, 2, 3x. This is the answer right here. 3x. All right, now let's take a thought here. I want to tell you why it isn't what some of you put out. Here's another thing I saw. 3 and an x. This is not what this means. This one here is 3 and x. Is that the same as this? No. This means multiply. It doesn't multiply mean sets of. This means 3 sets of x. So isn't that the 3 green? I also saw this one a couple times. What are the blues?
They're Y. No, they're X squared.
They're x squareds. Do you see a squared here? Brittany, are we with me? Do we see a squared? Kaylin? There's no squared, so we shouldn't be using the blue either. Okay? This number right here, I'll be with you in 1 sec, Reed. This number right here is called a coefficient. It could also be written as x plus x plus x. 3x is the same as x. Jeremiah, are you with me? 3x is the same as x plus x plus x. Read. Go ahead.
Thought of something. You know how X is just like barely more?
Mhm.
How much is the depth?
Not enough to be the barely more, if that's your question. It's not enough, but good observation. Aiden.
Coefficient are kind of like exponents, just not exactly the same way.
Ooh, they're kind of like exponents, but you're so on the money. What do you mean by that? They're kind of like exponents because they what?
Well, if you had you have 3x, it's x plus x plus x. If you had 2x, I think it would be x plus x. If you had 4x, it would be x plus x.
Excellent. He said 4x would be x plus x plus x plus x. Sorry, that plus didn't look like much like a plus. If you had 2x, he says it's x plus x. What happens if you had this? What is that? Is that x plus x?
No.
What is it?
It's x times.
Yeah, that's right. Powers have to do with multiplying. The coefficients have to do with addition. It's really how many of them you have. All right, so right there at the top of your note maker, it says, what is a coefficient? What is a coefficient? So what is a coefficient? Let's figure out some kind of definition. What is a coefficient? Thoughts? You look thoughtful. Thoughts? What is a coefficient? Do you think you have a good one?
The whole number.
It is. It is. In this case, it's a whole number. It doesn't have to be, but it could be. Okay, we could also have half x. That means you just take a knife right down the center and cut x in half. Okay, or divide it into 2 pieces. A coefficient is, help me out. What's a coefficient? Yes, ma'am. Where is it located? Just out of curiosity. Where is it located? Aiden, go ahead. It's before the variable. Coefficient, so we can put a coefficient in front of the variable. Write with me, please. Write on your note maker. A coefficient is in front of the variable, and what does it tell you? It's in front of the variable, not behind it. It's in front of the variable, and what does it tell you? Chrissy.
To add the number of variables.
I know that's kind of a weird thing to say, but you're right. It tells you how many of that variable we want, because that's another way of saying adding. So a coefficient is in front of the variable, and it tells you how many of the variable we want. A coefficient is in front of the variable, and it tells you how many of that variable we want. I'll give you a couple problems, and you are going to turn to your partner, and you're going to say, the coefficient of this one is. Guys, why are we inside that? Are we okay there? Do we have what we need? Okay. Okay. What I'd like you to do is switch off with your partner, shoulder partner. One of you tells number 1, and your partner has to agree or disagree. Then you switch. The other partner tells number 2. The first partner tells number 3, and the last one tells number 4, and you have to agree. So, but here's how I want you to say it. Listen. I want you to say the coefficient in number 1 is. The coefficient. You need to say the words, okay? So I need to hear you say it. Ready? Go.
Trying to kill Bob.
I want you to listen to Brady because you may or may not disagree. Here's what I want you to do. When we're done with Brady, when Brady says the coefficient of number 1 is this, I want the signal right here. Notice where I'm putting it. I don't want to hear. I don't want back here. I want your signal. Yeah. It's a thumbs up. I agree. I disagree. Not in Brady's face. He doesn't need to see that. It's for me to see. Do I agree or disagree? Okay, right here in front of your chest, okay? Brady, can you tell me number 1? Say it in the words I asked you to. The coefficient is? 4. Let me see. Agree or disagree? And I know, Brady, you agree with yourself. Orlando, I can't see your signal. Matt? Yes. I need to see if you agree. Can you put that back up on the table? And please show me. Agree or disagree? I agree. Okay, this is the signal, appropriate signal. This or this? He is absolutely correct. The coefficient is 4.
I thought it would be 4y squared.
It's not. A coefficient is a number. It tells you how many. It's not a variable. It's a great question. Read. People make this mistake all the time, and they're always trying to say it's the variable itself. It is 4. There are 4 x squared y's. Remember that was that funky rectangle that was like a 3-dimensional? There are 4 of them. Okay, it tells you how many. Excellent. Thanks, Brady. Number 2, want to attack number 2? Miss Sydney. No, say it out loud for the, use the vocabulary. She says the coefficient is 3. Do we agree or disagree? Okay. Paloma, excellent. She is absolutely correct. It is 3.
Oh.
It is 3.
I thought it was 3. Oops, I meant
Oh, you thought I was going over here. No, it's 3. Okay. Who would like to attack number 3? Zach wants to attack number 3. The coefficient is... Okay, do we agree or disagree? I don't see James. Agree or disagree? Ben, Sydney? Agree or disagree? You said the coefficient is 1/2. Unsure. That's what that means, unsure? It's absolutely all the way right. It is 1/2. It is the number out here in front. It doesn't have to do with M. That means that if you had a shape M, you'd have to cut it in half. If you had a shape M, you only want half of it. Kaylin, you want to check this one? Okay, let me hear it.
The coefficients of 4 are 2 and 3.
He's correct. I'm not even going to let you do this. So I know that a lot of you are confused. Coefficients, there's more than one. The coefficient to x is 2. The coefficient to y is 3. Nice job, Kaylin. Okay, so let's do some modeling. Let's get some tiles ready. The next question we have is, how do you model with algebra tiles? How do you model a coefficient with algebra tiles? Yeah, that lovely modeling. Lovely spokes modeling. Ready? Alexa. Mm-hmm. Okay, do we use these to represent the coefficient? Alexa said this might be more efficient. Zach says no. Do we use these little guys to represent the coefficient? No, and that's one I would be, it seems like it would be faster to do that. But what it's telling you is how many of these variables we want. So would you please show me on your desk in front of you that? I want to see this modeled. Okay. Orlando, are we ready? Matt, are we ready? Model that for me, please. Brittany, did you see what I'm doing? And packing up the tiles? No. This. I have one on the board for you to model. Kaylin, I don't see me model. Nope, look again. Look at your tiles again, Bryson. Ooh.
This one?
Help yourself.
Is this one?
Why don't you?
This one good? Don't tell
Oh. Is that? There we go. James has the modeling. Absolutely perfect. There they are. Negative 2x squareds. It's telling you how many of them you want and what color they are. Positive or negative. James, thank you so much. Like that. Okay, are we ready for some difficult ones? Let's see if you can model this. Show me that. Where is it?
Got it.
Elizabeth,
Wait a second.
knock yourself out.
Wait. There. Got it.
Okay, Elizabeth's going to model it for us up there because I see some that are a little off. You really have to be thinking about what it's asking for. There we go. It's asking for 4 x's and 3 little ones. Okay, excellent, Elizabeth. You did perfect. So tell me this. Do the yellows have to be in front? Can they be here? Is that the same thing? Can I put them up here like this? Is this still 4x plus 3? Is this still 4x plus 3? Okay, here's a thought. Is this still 4x plus 3? It's 2x plus 3 plus 2x, which is the same as 4x plus 3. Does the plus 3 have to be at the end? Can I write this as 3 plus 4x? Sure, why not? Can I write it 4x plus 3? Can I put the 3 underneath it? Yeah, that's the same thing as moving the tiles around. Awesome. Now, on your note maker it says, how do you model coefficients with algebra tiles? How do we model coefficients? Where do they show up? Now you got it. Tell me.
So these were the 3x.
You need 3 of them. That's exactly right. So how do you model it with algebra tiles? You should be having a pencil in your hand ready to write. It's on the left side with our essential question. How do you model a coefficient with algebra tiles? It's how many of that tile you need. So if you want to put 3x means 3 strips, or 2x squared means 2 big blue, that's fine. But it tells you how many of that shape you need. That's how you model it with algebra tiles. It tells you how many shape, or you can give yourself an example. 2x means 2 strips. Good job. All right, I'm going to put some on the board. Let's see you model them for me. I want to see tiles moving on desks. Are we ready? Read, not tiles moving like that. Ooh. Keep up if you can, my friends. I need to see it in your space.
Negative 2x squared. 2x squared.
Oh, so that would be 2
Minus 3x.
minus 3x. I think I got it. I think I got it. I think I got it.
Okay, Miss Sydney's showing us. She has negative 2x squareds. Notice it's red. Negative 2x squareds. X squareds are the blue, and the opposite means flip them over, and we want 2 of them. And Alexa told us that if we need how many, with a coefficient tells us how many we need. Then Sydney's putting us up 3 x strips, and she made them red. And then 4 negative 1s, okay? So right now, would you tell your shoulder partner, go ahead, thank you, sweetie, what the coefficients are in this expression? Say the coefficients are... James, I don't hear you modeling. I heard you. Okay, the coefficients are, what are the coefficients? See some good stuff. Jeremiah, what are the coefficients?
Negative 2 and negative 3.
That's correct. And this is, it almost seems like this, but it's of ones. So it is its own coefficient. It's kind of strange. But how many x squareds? Negative 2, which is the coefficient. How many x's? Negative 3. Or you can think red, giant squares, red little strips. Okay, good job. Okay, here we go. Aha. I'm on you on this one. This one is around. Okay, let's take a look up here. Chrissy is modeling. Let's double check. Okay, I should be toward the front. First of all, she needed 5 yellows. It says 5. Got to have 5 yellows out there. There are no variables in that 5. So there are 5 yellows. Go for it. She needs 1 red because it said negative x. X is a strip. X is a green, but it says negative. So she had to put the red. And it says and an x squared. So you need a blue. It should be 5 yellow, 1 red, 1 blue. 5 yellow, 1 red, 1 blue. How come these two together? Some people were like, well, that's a positive and a negative. They'll wipe each other out. Are these the same army? No, they're not even the same shape, are they? We have x squared and x. You can't add them together. They're not the same. This is an additive inverse. This is not. Okay, but I'm glad you were thinking of additive inverse. You were getting there. Okay, clear off. Let's try another one. Okay, there you go. Model it. All right, Jeremiah is going. Let's see where we are. I think some of you think you have it. First of all, we need a 2x. Oh, Jeremiah went anywhere into the problem, which he absolutely can do, and modeled a 3x squared. There's the 3 blue. Sorry, sweetie. Then he decided, yeah, I'm going to go backwards, so I'll take the negative 4. See the little 4 squares? And then we needed our 2x. He's stepping them on top. Can they add together? No. He's putting them on top of each other around the side. Does it make it a new shape? Yeah. Did these two, when you put in 2x and the 3x squared, did that become 5x squared? No. It's still 3x squared and a 2x. Doesn't matter how you rearrange them.
It looks like a rig gun.
It does, but it's still 3x squared and 2x. Notice he didn't have to go in any particular order. Your variables can be anywhere in the equation. Okay? Good job, Jeremiah. Thank you. Okay, so now if we know how to model, an expression, you're playing. If we know how to model expression, we should be able to take expressions and add them together. If that's what we can do, we should be able to take very complicated expressions and add them together. This is just like taking 4 and negative 5 with the little squares, except for now we're going to be messing with 3 shapes at the same time. Can you handle it? Okay. No. Tell me what would happen here. If I added 2x and I brought in negative 2x, what would happen? See some good stuff? What would happen? Some people are still thinking. Paloma, what would happen?
They don't go together and make an added inverse again.
Yep, look at them. Line them up. What happens? Oh, gentlemen, thank you. This is what happens. Oh, sorry. It's an additive inverse. 2x and negative 2x. Notice they're the same shape. They'll take each other out. What would be the additive inverse of x squared? What would be the additive inverse of x squared, the blue one? Go ahead, Christine.
Negative x squared.
Yeah, these are the additive inverse. You have to have a red big square to take out a blue big square. Okay? All right, here we go. Here's what I want you to do first. I hear a lot of shoes and fightings over there. Not that that's a bad thing, but we'll keep it as a min. Model this expression for me. And notice I'm putting it in parentheses, means I want that to be its own expression. And then next to it, and I do not want you to put parentheses or put a plus by modeling it with tiles. No, no, no. I just want to see these tiles, and I also want to see these sitting next to it. I want to see two expressions. Can you do that for me, please? Let's see if you can follow directions. I want to see two expressions sitting next to each other. I don't want a plus modeled in between. I just want two expressions sitting next to each other. Can you do both of them?
4x negative 5.
Where are you at, Kel?
Minus 5
Good. And this is?
minus 3x and plus positive 2.
Perfect. Go ahead. Okay, Nicole is going to model the two expressions for us. Make sure you're modeled exactly like hers are up there.
Did I get this right?
You are absolutely correct. Bryson, would you please check your whole table?
Oh, and what if they're still right and they're not exactly like hers in a different shape?
Well, then they wouldn't be right. You have to be exactly the same shape. When you say an x squared, that's different than saying an x. So be careful where you don't interchange them.
No, I meant like this.
I don't
I
understand.
meant like this.
Oh, okay. I meant like, oh, I see what you're saying. You had something in between them separating them. Okay, let's take a look at Nicole's work. She's got 4 x's that are green. So the coefficient in front of the very first x is 4. Thank you, Kaylin. Once again, the coefficient in front of the first x is 4. Thank you. And then she has minus 5 little squares. Nice job, Nicole. And then she's got 3 negative x's and positive 2 yellows.
Okay, I'll make it exactly like hers.
Did everybody get that? Are we there? Waiting. Alexa, how are you doing, sweetie? Catching it with me? Brittany, how are you doing? You got it with me? Okay, I know. It's not quite time yet. Okay, here we go. Now, what you're going to need to do is you're going to have to combine these together. You can take algebraic expressions. Kaylin? Aiden? You can take algebraic expressions and you can combine them. You can add, subtract, multiply, and divide expressions. You can do that to algebra.
But wait, wouldn't some of those, since some of those are the same shapes, wouldn't some of them kill each other?
You are absolutely right. So what happens is, in order to add them, what do you have to do? You have to put the same shapes near each other, don't you? They're not any good separated from each other. Would you do that now on your table? Would you move the strips next to each other and the one tiles next to each other? Don't do any fighting yet. Alexa, what question? Okay. Here's what I'm doing. On the left-hand side of your sheet of paper, it says, how do you add, subtract expressions together using tiles? And then we have without tiles. But we're going to do with tiles. So what happens when you're adding and subtracting an expression? You take and you rearrange. You have to put the like shapes together. So would you put that down as your first step? Like shapes together. Like. So in other words, squares have to go with squares, strips have to go with strips, teeny tiny squares have to go with teeny tiny squares. So that's our first step, is putting like shapes together. In mathematics, that's called combining like terms. Have you ever heard that before? Yep. Combining like terms. That's the same thing as saying putting like shapes together. That's your first thing. Notice how I regrouped them. Are yours regrouped on your table? Okay. Put your like shapes together. Now what? Let's look at our tables. Look at what I'm doing up here as well. Matt, are you with me? Thank you. Let's just look at the X's for a second. We have 4 green and 3 red. What happens when you put a red and a green together? They cancel each other out. They're called the what? Additive inverse. So let's take one set, a second set, a third set, and what is left? 1x. Okay, come back from your wars. Come back from the war, please. Thank you. All right, let's look at our ones. Gentlemen, that wasn't an invitation to talk. Let's look at our ones. We have 5 negatives and 2 positives. What does that mean? We line them up. What happens? We have additive inverses, right? And what's left? And -3. Let's look up here for 1 second. What is 4 minus 3? Look up here. I can't see everybody's eyes. This is really important because this is how you do it without tiles. What is 4 minus 3? 1. Remember I told you you didn't have to put the 1 there. What is -5 plus 2? -3. Thank you. So in order to add together, what do you have to do? In order to add together, what do you have to do? Yes, sir. Yes. When you add together, what do you have to do? Go ahead. You have to put the like shapes together, and then the next step is to look for what? What do we call them when we put them together and take them off? Yes. That's right. You're going to cancel out your additive inverse. Second step, write with me, please. You need to cancel out the additive inverses. Now, the problem is if these get too big for tiles, sometimes you can't use tiles. Look, if you look at some of the problems off to the right on your paper, you're going to be like, yeah, I don't have tiles to do those. Okay? So what does that mean? From here to here, did I add the x? Did I do anything with the x's? Did they become x squareds? No, they didn't become x squareds. What did I add together? What are these things called? Use the vocabulary. What are these things called? Paloma? Coefficients. You have to cancel out additive inverses, which means add or subtract. Coefficients. Use the vocabulary. You should be writing this, please. Those steps should be in there in that left side of your note maker. Excellent. Right here, Cal. 3. So would you put 2x squared plus 3x minus 1? I need to see it in front of you somewhere. Okay, so I got to be able to see it before you start putting it together. That one up that, see in the parentheses? 2x squared plus 3x minus 1. You're going to model it on your table. And then we also modeled 2x minus x squared plus 4. So we have 2 expressions. They're called expressions without the equal sign. 2 expressions modeled right in front of you. So I'm going to be looking around to see if I can see it.
Wait, what? What are we?
Oh, come on now. You got to be with me. My lovely spokesmodel is going. Did we get that for 2x squared plus 3x minus 1?
Yeah.
Does she have to put it in the order that I wrote it?
No.
No, very good. That's called the commutative property. You can rearrange as long as you keep the negative sign with its partner. Okay, there's the first one. Can you do the second one? Leave it up there, though, for me. And now she's going to do 2x minus x squared plus 4. 2x should be 2 green strips. Minus x squared should be 1 red x squared. Not 2. There shouldn't be 2 red x squareds. I see that on a few people's. Right. And then a plus 4. Take a look. The coefficient of this one right here, of the x squared, what's the coefficient? 1. It's -1. Here, the coefficient here is -1. There's no 2. That tells you what shape it is. X squared, that 2 up above, tells you what shape it is. Yes, ma'am? No. 2x is green strips. Okay? And if you can see, Brittany, can you see from where you're sitting? and I know that some people can't, but I still have the chart that we made over there to double check. You're right. It's such a hard distinction between x and x squared. I'm glad you brought that up. Reed, question?
Then I brought it together already.
Did you bring it together already? Okay, so Reed's going to put like shapes together. So let's do it with tiles first. We're going to do it with tiles first.
Oh, do you want the answer or what?
Do I want the answer or what? Or what? No, I'm just kidding. I'm going to put the big giant squares together. I'm going to put the x's together, but notice I'm keeping them a little bit separate, and my tiles together. So what I said here, because eventually I'm giving you problems that are harder than tiles. In other words, you can't use tiles with them. I'll say 36x squareds, and you're done. You don't have 36x squareds. Okay? I might call them mn instead of x. It's still a variable, but you don't have the tile for it. You okay with that, Bryson? You good? Okay. So you have to get used to doing the symbols as well. What we need to do is we need to regroup the shapes together in parentheses. So I need to do what I did up here in symbols. This is the hard part. This is where I'm talking advanced algebra for you right now. If you can start to follow me, you are way going far. Okay? If you can't follow me, that's okay. We'll do more practice together. Read.
Can I bring it into the answer form right now?
In one step. Can you let me take one step and then you're going to put it in the answer for me? Okay? If I'm going to deal with the x squareds first, they're my biggest shape. Bryson, right? They're my biggest shape. Who's grouped up here? Do you think you can tell me, bud? Who's up here? Tell me what these two guys are. Okay, how many blue x squareds? 2. So 2x squareds. How many red? Good, a minus x squared. You didn't say 2. That was awesome. Okay, now I have my greens, and I know they're separated. Are they hard to see for you back there? Can you see them? Okay, so how many in this group down here? 3x. Mm-hmm. And plus 2x. Very good. And then the last are the little ones. 4 yellow. I know it's really hard to see the yellow. Good. Plus a -1, or you could have written it as -1. Do you see how to regroup them? How the shapes are together? Our last step was to look at the coefficients. That's what we're going to be adding or subtracting, coefficients. What is the coefficient? Is that the x or the number? Yay. Very good. All right, Reed, finish it up for me, my man.
Okay, so the answer to the question is 1x squared
Mm-hmm.
plus 5x
Excellent.
and plus 3.
Good. There must have been some additive inverses there, yes?
Yes, I just put those together.
Yep.
Nope. And put the 2 ones together.
Uh-huh. And then these had an additive inverse. Okay. Look at here. Look at the parentheses. I need to see eyeballs up here real quick. Thank you for writing that down, Brady. I appreciate that. Zach, I need to see your 2 minus 1. Do you see the coefficients? 2 minus 1 is 1. 3 plus 2 is 5. 4 minus 1 is 3. But I still have to keep my variables. Okay, that's the secret to doing this. Okay, you ready to do one on your own? Are you ready to do one on your own? Yes, of course. It's not even hard. I know, thank you. You see me wake up. Scary. Okay, this time I want you to model it, write it. So you put your model up. Okay, you write this down, put your model up. Regroup, move your shapes, write this part. Okay, move your shapes around, and then see if you can look in the parentheses and make your answer match. Because I knew what my answer was supposed to be. If I mess this part up, it won't match my tiles. Okay? Do I need to model it one more time, or can we do one? Let's see how one goes, because we've done this a couple times before. Let's try it ourselves. So you're going to write it down, model it, move the shapes, write again. Then you're going to clean the shapes up, see if you can solve the problem without looking at the shapes, and then see if they match. Okay. Okay, see if you can do that one. And please, feel free to use your shoulder partner. What do you have? What do I have? Do we have the same thing? That's really important. You can talk it out. It is 3x squared minus 2x minus 4. It's the first one. 3x squared minus 2x minus 4. Then plus, and in parentheses, negative x squared minus 2x plus 3. Okay, you got to let Zach catch up to you, though. Zach is going to model the equations to start with. I think a lot of you had them that I saw. I didn't really see any incorrect modeling. So we really have the algebra tiles down. Woohoo!
Shoot.
Tricky?
Yeah.
Yes.
I just don't get how to solve this.
3x squared.
Okay. 3x squared, there you go. Minus 2x.
2x.
Okay. The next step, according to this, is to group. Very. Okay, so now how can you write that first? Don't do it yet. Do it like this or you'll never remember. That's the first one. Okay, let's put up the second one. Do you see what I mean? So now write this plus this in parentheses. This plus this. This plus that.
All right.
In parentheses first. Okay, and Zach is putting up our negative x squared. Excellent. Our minus 2x. Ooh, I see good stuff over here. So you have two, where's your, oh, can you move it down for me, Zach? Thank you. It's like up into the chemical periodic chart up there. It's hard to see. Okay, there we go. So this is minus 2x plus 3. Can I see thumbs to me? How many of you were able to model it correctly at the very beginning? Thumbs to me. Good, Noah. Without being here, that's really good. 2 thumbs, I see. Brady, good. Okay, good. Thank you. All right, so the modeling starts first. Now, what Zach has to do, our whole point is to like terms, right? Put the like shapes together. So Zach is going to just sort of rearrange them, but would you make sure that if they're the same shape and color, just kind of put them on top of each other, if that's okay? So Zach's going to rearrange, and what Paloma's going to do is she's going to do it on the board with us. Okay? So he's going to put the squareds together. What would that look like, Paloma, in parentheses? He has 3x squareds right there. See how he has them? And then he has a negative x squared. Can you put those in parentheses for me together? Good. Can you separate those 2x's? Negative 2x's? There you go. So she knows that they're 2 different groups. Excellent. This would be the second step, what Paloma's doing now. In the same parentheses, sweetie. There you go. Perfect. Okay, so she put 3x squared minus an x squared. Now plus. We're going to combine it with. Good. And now the x terms, negative 2x and a negative 2x. Did you have this step? If you're missing this step, you're going to get creamed when you try to do the harder problems. You need to remember which ones are the same shape and put them together. Good. And go ahead and close that parenthesis up. And, so that's a plus. And, good. And now she's got to deal with the ones up there. So she's got 3 ones and 4 negatives. 3. And does it matter if I put negative 4 and then plus 3? No, Kaylin's right, because Kaylin's listening to me. Thank you. And go ahead and close the parentheses. Okay, that step right there. Do you have that step? Turn around and look at what Paloma's doing. Stop rearranging your tiles, Jeremiah. Look at what she's doing. Do you have that step written down? If you don't, you're going to get clobbered the next time you try to do a really hard problem. You got to have it where you regroup the same shapes together. Okay, what's the same shape? Jeremiah's nodding, so I'm assuming he has that written down. Good. Okay, now before Zach finishes the tiles to check, Paloma's going to finish this one by just looking in the parentheses. This is the part, Matt, that you were kind of concerned with. Look in the parentheses. What is 3x squared take away an x squared? What's 3 minus 1?
2x squared.
2. Good. So she puts a 2, and then don't forget your variable, which is x squared. Yes, ma'am.
It's weird because if it's 2 now, it doesn't look like that. It just looks like the answer would be just flat out 3 because it's 3x squared, and then it's saying take away the x squared of it.
So you almost imagine that the variable would go away, huh? But that's not what it's doing. So when you think of the tiles help you from making those mistakes. It's a 3x squared, 3 blue, take away one of the blue. Okay, so you have to think about that. It's not going to get rid of the variables. Okay, so she's got 2x squared plus a negative 4x plus a negative 1. So what Zach's going to do is going to check her. Any additive inverses there? He got rid of that one. Go ahead. There's an additive inverse there. He got rid of, ooh, a whole bunch of them there. He got rid of. And what does he have left? He has 2x squareds, which Paloma has, 4 negative x's, and negative 1. Okay, let me see here. How many of you got that right? All the way down. How many of you got it right? It's right here. Thumb plus or minus. You don't have to rub it in someone's face.
I got it right, but I don't think I modeled it right because Chrissy said I did it wrong.
And you know what? There's a couple different ways to model it, but the modeling is the hardest part. Seriously, the modeling is the hardest part. Okay, good. Thank you, guys. Thank you very much, lovely spokesmodels. One more, since some of you didn't quite get that, but I think you now are ready to go, right? We're all ready to go. Here we go. Same steps to be able to do it. Okay, write, model, write. Okay, put the parentheses, figure it out on your paper, then go back to your tiles and see if you have it right. This is the trick. To try to do it with symbols, get your tiles ready, figure it out with symbols first and see if your tiles, if you're right. It's the most important part. It's going to check you to see if you're correct. Okay, how's Jeremiah doing? He's got my 4x, the negative 2, and the plus x squared perfectly. We've got the 3. He's looking for negative 3x and 2x squared. There we go. So he's got it modeled. Now, the first step is to do what? Waiting for my group. Once you have it modeled, what do you need to do? Go ahead. Like terms together. That's the same shapes together. So as Jeremiah is rearranging, Kaylin's going to be writing for us. So he's going to start with which one? The x squared, good. And he's going to put that with the 2x squared. Please don't forget your exponents, that x squared. It's different to say x than x squared. Good. And Jeremiah rearranged them. Excellent. So Kaylin's going to keep writing. He's got a 4x and a minus 3x. Good. And he's got a... Not yet, but it's almost your turn. Minus, you got to wait for Kaylin to keep writing. He's got a 3 and a minus 2. How do we do on writing that step? Look up at what Kaylin's got. Were you able to find the right ones? Good. I see some thumbs up for me. Good, thank you. Dylan, how about you? Okie dokie? Okay. All right, now, Kaylin's going to take a second before Jeremiah starts attacking the tiles. Kaylin's going to look at, no, not yet. Kaylin's going to look at the coefficients and see if he can put them together by himself without the tiles. I know he would. That's why I like Jeremiah. Okay, so he looked and saw x squared and 1x squared plus 2x squared gave him 3x squared. 4x minus the 3x, so 4 minus 3 is 1x, and 3 minus 2 is 1. James, is that what you got? Mm-hmm. Okay, now Jeremiah, attack. There we go. There we go. Oh, what does he have left? 3x squared plus 1x plus that one little yellow that's skimmed off to the side. Not the 2, though. There's 1, Jeremiah. That's right. You grabbed the wrong set of yellows. Good job. Good job. Perfect. And we have a ray gun. Awesome. Okay. So how do you do it when it's even more challenging? How do you do it when it's even more challenging? Let's take a look. You got to keep straight what you're doing. We're going to write this on our regular paper and see if we can do these. This one's much harder. No parentheses this time. You might be able to do tiles, you might not. What about something like that? That's quite the animal. It's not in 2 groups anymore. It's one big old long stream. Zach thinks he has a plan.
I think I have a plan. Me too. Back to paper. I'm scared of X's now.
I'll show you that one too. There's way too much stuff. How about you talk as a table group and see if you come up with a plan. What's our plan? How are we going to solve that with a plan? We need a plan. Talk as a table group. What's your plan?
Order of operations?
Well, actually, basically says it's all religious. Yeah, that one.
No, no, it isn't.
No, because X is the variable, not actual.
Brittany, are you talking to Kaylin? You can also include Alexa down there as well in that plan.
So we group them like four.
Jeremiah, you guys coming up with a plan? You're still writing. Then come up with a plan. The plan is not to run away from it scared. Not an acceptable plan. You think you have an answer? Good. Good. I'm glad you do.
Mine is 6.
Matt, we don't have enough tiles to do this.
So I got the extra.
If you combined them, you might be able to. So you could be able to check your work if you put your tiles together.
Yeah, just keep at it.
If you try, Ooh, some of you are already trying to solve it. I'm impressed. Oh, hello. We have people who are done. That's the problem. So now what are we going to do? What's our plan?
I know what my plan is. Get the answer without knowing.
But you have to know where you got it. You do know where you got it, Reed. It's in your head somewhere.
Yes. It's in the trash bin.
Cycle.
Here's what I hear. What if we combined our tiles? We'd have enough tiles. Good plan. Secondly, what if we just follow what we've been doing already? Group the like stuff together. Do we have some like stuff up there? Good. We have some x squareds, don't we? Shouldn't be talking. Hello. I like that some of you did combine your tiles together. And we can do that to check our work. Nicole?
Wait a minute, I hear some talking. Can you
Which x squareds are they? Do we have x squared terms up there? Read.
Well, we have. Okay. Well, we have 3x squared,
Mm-hmm.
and we also have 4x squared. So, and then just add them together. Additive inverse occurs. You go down again. You get 1x squared.
Absolutely
or
correct.
just x squared.
Or just x squared. Good. Do you see how I'm grouping them together? Here's what happens when the problems get real complicated. You know what I do when I'm done? Used them. Because when I'm going to start to put some of these out here are outrageously long. You might need to keep track of which ones you've already grouped. Okay. There's still more. There's still more. That's right. Rennie says there's still more. Noah?
Since there's a lot of x's, don't you number like 5
No. Great. Noah thought of it because Noah wasn't here last time. He's like, won't the 5 strips be the x squared? What did we learn about the 5 strips and the x squared? If you set them on there, go ahead and do this, Noah. You get a chance to do this. But go ahead and put your strips on there. You'll notice, Chrissy, what will you notice?
There's just a little strip at on the side, and
They don't exactly match. No, that's why you can't exchange them. Okay, how many, what do I have x's up here? Do I have x's up here? Is only Reed the only one that was able to do this? Do I have x's up there?
I got it.
Ben, you found the x's? Okay, so Ben, what are my x's up here? Ben, what are my x's? I'm saying Ben, but I'm not hearing Ben. Did I put you on the spot, Ben? Did you not know?
Oh, I know. I can't
Here, let's look at, turn around and look up here for me, Ben, okay? Do you see any x terms?
Yeah, the 4x,
4x,
the 9x, and the 6x.
the 9x, and the negative 6x. Good catch. Take a look then. I have this one, and this one. Is there anything left, by the way, up there? No. So can I add 4x and 9x and negative 6x? Sure. What's 4 plus 9? Everyone can tell me. What's 4 plus 9? 13. Good. What's 13 minus 6? 7. So how many x's do I have? 7 x's. I have, my answer is x squared plus 7x. How many of you got that one? Ooh, I saw some really close too. You got it? You got it, Bryson? Good. All right, Smarties. All right, Smarties, here we go again. Do you want a real brutal one? All right, here we go. Okay. Let's see if you can handle this one. Uh-oh, I threw another shape in. Can you use Algebra Tiles now? No, we don't have cubes. Ching, now you're out of Algebra Tiles. You might want to be working with someone else to figure out your plan on solving something like that. Okay, I threw a curveball at you, so let's see if we can figure out what this curveball is. Okay, stop solving for 1 second. Stop solving for 1 second. And that means talking to 3x to the third. Do you have a tile for that? No, it's this one right here. It's a cube. It's x cubed. So there's 3 of these sitting out there. Will these combine with one of those? Does this become something? No. These don't add together. They are separate shapes. They don't get grouped together. They aren't going to add together. This is x to the third. So what you have to do, and this is what I told Brittany, if you're having trouble with this, I noticed that she's very color oriented and she color codes really well, is you say this is a particular shape, I'm going to underline it in brown, then I'm going to look down the way and see if I find it anywhere else. What is this a tile that we know? What tile is it? The blue square. I'm not going to underline it. It's not a cube. Cube? Yes or no? No, that's a strip. Yep, that's a cube. No, that's a square. No, that's a strip. So I put those together and then I'm going to go through with another color. You got colors on your table. X squareds is this one you said? And this one, right? Then I go through with another color and say, okay, I have my X strips and my X strip. So what you're going to do now is you're going to put your common colors together because this and a strip do not add. This and a big giant square don't add. The only thing this would combine with would be another cube. Okay? So if I put them together, I get 3x cubed minus x cubed. If I put my squares together, I get 7x squared plus 3x squared. If I put my strips together, I get minus 9x plus 6x. That's when you regroup. How did you do? Some of you are doing this mentally now, which is awesome. I know there's like 2 or 3 of you are doing it quick, mentally. Okay, so what's 3x cubed minus 1x cubed? Go ahead, read.
2x cubed.
2x cubed. 7x squared plus 3x squared? 10x squared. Very good. Negative 9x and 6x? Negative 3x. You got to watch. The 9 is bigger than the 6. This should be your final answer. 2x cubes plus 10x squared minus 3x. There are people getting it, huh? What? It doesn't have to be in that order. So Paloma, I could put it as like this. I can do it this way too. There's another way too. Okay, there's a lot of ways. As long as each one of them is attached to the right coefficient and the right sign, then you're fine. Good for bringing that up. Can you do me a favor, please, where you're sitting? I'm waiting. Oh, you need your tiles out still, Bryson. Can you do me a favor where you're sitting right now? You should have tiles in front of you. I have 2 expressions up. Can you just have both of them modeled in tiles? See how quickly you can get those two expressions modeled. Is there a lovely spokesmodel who would like to model them up here for me, please? Nicole, go for it. Up on the white. Nicole has not had a chance to get up there yet. So as soon as I do one other example, I'll sit with him. Do you mind if helping wandering with the really good the group? It's fine. Okay. There's just a couple little integer issues. That's all I'm noticing. Okay. Oh, some people have it already? No, you do not. Come on, hurry up. And Nicole is hustling through. She's got 2. Oh, don't put them together, sweetie. Can you make them as 2 separate? Perfect. Yeah, like that. Exactly. And now down one below it then.
Oh, done.
Yeah, don't combine them yet. Just model them. Reed, do you have a model?
I have the answer.
You do? That's interesting because this is a new kind.
Integers are actually
Ooh, I'm impressed.
integers are actually familiar. I program a lot.
Nicole, excellent. Yeah, really? Then you're used to them. Awesome. Perfect. Thank you, Nicole. Okay. Do you have, whoa, I'm waiting, there's some chatting, separate chatting. Do you have modeled in front of you, because you need to have it actually read, not just the answer, you need to have it modeled in front of you right now, because this problem looks a little bit different than the ones we've done before. So make sure you have the 2x squared plus your 3x, and then I have my negative 2x squared and 4x. Do you have that in front of you right now? No? Still waiting for? Okay, thank you, Nicole. It was hard for you to catch up because you did it for me. I appreciate that. What's different about this problem than the ones we've already done? I don't think some people have noticed it yet. What's different about this problem than what we've already done? Turn to the person next to you and tell them what's different. I hear it. If you didn't notice it, what's going on right there? Oh, whoops. It's a takeaway. It's a subtraction. It's a negative. It's an opposite. The last problems we've been doing, I know you do. Give me a second. The last problems we've done have all been plus, have all been combined. These are all the opposite of. So if this means, look up here, please. Thank you. If this means the opposite of, what is it the opposite of? Lexa? It is the opposite of addition. It is negative. So if it's the opposite out here, Kaylin, what do you think that means?
That means the answer was negative.
Possibly. That's a good thought. Possibly. Jeremiah, what do you think?
That the second problem, minus 2x plus 4x, I think that one will be reversed.
Absolutely. It means this stuff and the opposite of this stuff. That's why the minus sign is in front of the parenthesis. It means the opposite of all that stuff inside. Well, when you're talking about the tiles, what does it mean to say the opposite? What do you do to the tile? You can say it out loud. Flip it. So, am I flipping the first set? Wait. We all good? Am I flipping this one right here? No, because that one doesn't have a negative in front of it. But I am flipping the opposite of this one. So let's flip them over. Go ahead and flip them over right now. Flip over each one of those, but not the first set. That's not what we want to flip over. Now the problem looks a little different, doesn't it? Here's what's happening to the problem. I'll wait until you're ready. Still some chatting. This is what happened. Did the first one change? No. Look what I did. I just got rid of the parentheses. Why? It doesn't matter. Nothing happened to them. But the second one did. This negative 2x became what? Positive 2x squared. This positive 4x became negative 4x. So if you look, this negative sign goes and changes. It becomes the opposite of everything inside. It didn't just change the first one. It changed all of them. So now this is like the problems we've been doing. Now can we regroup? Yep, we have 2x squared and a 2x squared. We have a 3x and a negative 4x, right? We regroup them. Do we have some additive inverses? Yeah. We have 2 plus 2 is 4x squared, and then over here we have a negative. What's 3 plus negative 4? Negative 1. Do I have to write the 1?
No, but it has to be with x.
But it has to be with the x. She's absolutely right. So it should be 4x squared minus x. Subtraction is a little bit harder right at the beginning because you have to change all the signs. One more time, look at me. Subtraction is harder because at the very beginning you have to change the signs of whatever it's next to. Not all the signs. It doesn't make everything different. It just changes the signs of the one it's next to. Turn to your partner and say that in your own words, somehow that you'll remember it. Turn to someone next to you. How are you going to remember that? Look on your green sheet for me. Just leave that there for now. Look on your green sheet right now.
There you go. That's mine.
That's all right. This question is up there. There's still a lot of talking back there. This question is on the left-hand side. How do you add expressions, add and subtract expressions together without tiles? Okay? Nicole, do you see where I'm looking? Oh, yeah, you need your own paper in front of you. Some of you moved without your own paper. One of the things that we said, the steps were you had to combine like shapes. And then what? Look at your green paper. Cancel out additive inverses. What do we have to do if it's subtraction? Write with me, please. If it's subtraction, what do you need to do before you move the like shapes and before you cancel out the additive inverses? What do you need to do first? Read.
Change the problem after the subtraction sign.
Good. Yeah. Or in the parentheses or whatever. So we'll say change. You need to have a change the signs, but it needs to be inside the parentheses. So you need to make sure you're changing the right signs, okay?
Wouldn't it be just after the subtraction sign?
It's after the subtraction sign is the other thing.
Even if it doesn't have.
However, some people sometimes, if it doesn't have parentheses, is right. But if it has parentheses, and if you just say after the subtraction sign, sometimes people only change the first one, and they need to put everything inside the parentheses. So this is something you need to add to your green sheet.
Everything. Change the signs.
Change the signs inside the parentheses. Okay, after the subtraction, you want to put after the subtraction? Good. Yes. Where we left off is looking at subtraction. Take a look if you can see. If you need to move yourself, Jeremiah, if you need to. Look at the problem over there. This is one that James kind of cooked up a little bit. He said, can you do 3 problems at once? Kaylin, up here. Can you do 3 problems at once? Can it have subtraction and addition in it? Yes, it can. Yes, I see Jeremiah going, yep, you can do that. So how do you do that? What is the first step then? If there's subtraction in the problem, what should we do? First step, if there's subtraction in the problems. Chrissy?
You flip everything over in the parentheses after.
Yeah. Will I change the sign over here? No, why? What is this? Is it subtraction? No, it's addition. So if I recopied all of these, because I don't need to change the first one, I need to change the second one. So what's the opposite of 3x squared?
2x
Squared x3.
What's the opposite of 3x squared? Negative 3x squared. What's the opposite of negative 2x? Positive 2x. Because if you flipped it over, what's the opposite of positive 3? Excellent. And then this one would just be plus 2x minus 5. So now it's this big, long problem, and you need to go through, and you would find here's an x squared, and that's all the x squareds I have. I'd group them. And then I'd go through with my other color and say, here's an x, here's an x, here's an x. 2 plus 2 plus 2. Okay? Then I'd go through and look for my ones and say, okay, here's a 1 right here, a 1 right here, and a 1 right here. And then make sure that I have all of my terms. I think Reed has an answer because he's been booking to try to keep up with me. Do you have it, Reed?
Right now I have 1x squared.
Absolutely correct if that's the black ones put
6x,
together. 2 plus 2 plus 2 is 6x is correct. And?
And since they're both of the negative 12.
And almost. Negative 15 is right. They're all negative.
3.
Yeah, you didn't see the 3. So it's negative 15. Good job. Good job. Okay, so you got to watch your subtraction. Will you take 1 second and fill out on your paper? It says, what does combining like terms mean? And how can you model it with algebra tiles? What does combining like terms mean? What does that statement mean? What do I mean when I say that? Rennie?
Combining subtraction and addition.
Almost. It's back from what we were doing before, so I kind of messed with you. I talked about subtraction first. What does combining like terms mean? What does combining like terms mean? Chrissy?
Put the squareds together and x squared.
Perfect. It's putting the same shapes together in Algebra Tiles. That's how you model it in Algebra Tiles. Outside of Algebra Tiles, you model it by just putting the ones that have the same powers, the same variables together. Can you take a moment and fill in that part of your green sheet and then check with your partners at your table to see if they have the same thing, if you'd like to change the phrasing. But combining like terms means to put the same variables and the same powers together. In tiles, it means same shape. Okay, here's what we're going to do. Yeah, that does work nicely as a parachute, doesn't it? Nice aerodynamics. One of the things that I want you to do now, if you look on that green sheet, you have two sets of problems. Do you see where it says level 1 and level 2? Okay, this is giving you some choices like we did with a warm-up when we did integers. You have a choice right now. You can start and do level 1. And if you're doing fine, you might want to look over to the right and say, what's different about level 1 and level 2? I might be able to do this problem in level 2. Okay, but I can't do the next one, so I'm going to go back to level 1. You need to complete. If you have all of level 1 done, that's great. If you can do all of level 2, that's some pretty high stuff. What do you notice about the difference between level 1 and level 2? Reed, what do you see?
Some of the ones on level 2 have decimals.
They have decimals. That bumps up the difficulty level. Paloma, what do you see? It has different letters in X and Y. Has A's and B's? Same thing, right? X, D's and C's. Yeah, the other one does have some. It has a D and a C, which means that there are some different variables, but that one is not as difficult as the one that has A's and B's. Okay? So you have a chance to talk to each other. I'm going to leave the answer key. No, I'm not going to leave it on the board. I turned that board off. It's going to be sitting right up here. If you want to check one of your answers, that's great. And you can check that. You can talk to the people next to you. If you complete all of level 1, you will have mastered this material. If you start to do level 2, that's fantastic. You're beyond.
Can you do level 2, then level
And then go back and do level 1. So if you finish all of level 2, then go back and do level 1, for example.